afternoon, everyone. First of all, I would like to take this opportunity to express my appreciation to everyone who has worked hard to put together the SIL2021. My name is Hyun Kim, and I have been Professor of Environmental Education of Sejong National University since 2001. In the last 20 years, I have been conducting research and data analysis and plankton dynamics and water quality in freshwater ecosystem in Korea. Well, it is a great pleasure and honor for me to introduce you the second plenary lecture here at the 35th Congress of International Society of Limnology. Professor Bomchul graduated from the Seoul National University with a degree in oceanography in 1977 and received his doctorate in lake ecology in 1987 with his research on Lake Soyang. In the early 1990s, he worked on DOC studies at Professor Robert Welch Laboratory at University of Alabama. Professor Kim has been conducting a long-term ecological study, Lake Soyang, for about 30 years. One of Professor Kim's most noted achievement would be his work on the harmful impact of fish excretion from fish farms on the lake eutrophication. His work inspired legislation of law that prohibit fish farming on lake. Also, as Korea has few natural lakes and large multipurpose dams, his work has also contributed on accelerating our understanding of ecosystem of artificial lake situated in monsoon area. Professor Kim's talk is titled Limnology Condition of Korea. I will be on insightful and a meaningful presentation about the journey of Korean limnology. All right, let's move on to the second plenary lecture. Please welcome Professor Kim Bomchul.
Okay, good morning and good evening. It is my pleasure to have an opportunity to introduce limnological conditions of a Korean freshwater ecosystem. Each country has unique features of natural conditions and cultural societal conditions. Today, I will give a general introduction to the natural condition of Korean freshwater ecosystems and some cultural conditions. First, I will introduce some physical and morphological features and then climate and eutrophication problems. And next, what is the cause of eutrophication in Korea and what we can do to control eutrophication in Korea. Morphology is a basic natural condition determining every aspect of chemical and biological features. In Korea is located in old granite geological formation with no glacial activity. So we have few natural lakes. So we made many artificial lakes, 17,500 artificial lakes. This number is much bigger than the number of lakes in Minnesota. Minnesota is a country of 10,000 lakes, but we have 2 times more. And we have many weirs for irrigation, more than 34,000. And most of rivers are transformed by river bank and weirs and dams, so rivers are regulated. Basically, Korean streams are small and short compared with large rivers in China and United States. And because Korea is a mountainous country, full of mountains, so most of rivers and streams are very steep and fast flowing. So gravel bottom is common in pristine area, which is favorable condition for periphyton growth. But we have many sandy bottom streams in cultivated area. Poor fauna diversity is a serious problem. Physical transformation is the major stress factor threatening ecosystem health in streams, I think. Most of rivers are surrounded by artificial banks, steep and impermeable to water. And we have many weirs fish can't go across. For climate, monsoon, summer monsoon is the most critical factor determining the natural condition of Korean freshwater ecosystems. In Korea, we have half of annual precipitation in July and August. The rainfall is severely aggregated in summer. We call it summer monsoon. And on rainy days, the river flow increase drastically. The bottom figure is the change of flow rate in a river. On dry days, the flow rate is negligible, but on rainy days, it increased drastically. So that kind of high flow rate in streams actually destroy all stream ecosystems, especially benthic community. Most of river bottom is disturbed, rocks rolling, and benthos washed off. So actually, it is a kind of reset of ecosystem in Korea. And in reservoirs, also we have very big impact. On rainy days, the flow rate increased by 1,000 times, and the phosphorus concentration increased by 100 times. By multiplying, we have 10,000 times more phosphorus loading on rainy days compared with dry days. So I call it episodic shock loading of phosphorus into reservoirs. So the effect of monsoon is exerted in phytoplankton growth. We have highest phytoplankton density in August and September. So I called it monsoon bloom because it occurs after summer monsoon. In Limnology textbook from US and European countries, you see spring bloom. Spring bloom is the highest phytoplankton bloom in lakes, but it is not the case in Korea. We have summer bloom, much higher than spring blooms. Water level fluctuation is also a big stress factor to lake ecosystems. This is the case of Lake Soyang. Within several days, water level go up 20 meters. So we have many wide, barren shoreline without no littoral vegetation. So benthic fauna diversity is very low. And I will talk about some eutrophication problem, water quality problem in Korea. In Korea, we have built many water treatment plants and sewage treatment plants. So now BOD is removed and toxic chemicals are removed. But still we have many serious eutrophication problems. Usually, eutrophication problem is known to be a unique problem in lakes. But in Korea, I think, stream eutrophication is severer than lakes. In streams, we have many overgrowth of periphyton like this. Major cause is flushing toilet. I put it flushing toilet at the first. In rural areas, recently we all have flushing toilet. It is very harmful to a freshwater ecosystem. In pristine areas, we have very good gravel porosity, gravel pore. But in eutrophic streams, gravel pore, interstitial pore is filled with periphyton, and it impairs benthic fauna, habitat, and spawning site of fish. This is a common problem all over the country. With the growth of periphyton, we have a large fluctuation of dissolved oxygen in eutrophic streams. This is a case of a stream in Seoul. Dissolved oxygen fluctuates from nearly 0 to 10 milligrams per liter. This large fluctuation of oxygen can be a stress to fish because fish should adapt to low oxygen physiologically at night and very high oxygen during the day. And also we have many supersaturation problems. Still, we don't have much knowledge about the effect of supersaturation, but we can see supersaturation problem in many reservoirs. Usually 110% is the guideline in the United States. In many places, I see supersaturation over 120% of gas in Korean streams. The major cause is eutrophication and oxygen production by periphyton. Large fluctuation, another case is like this. The daily fluctuation is almost 10 milligrams per liter. And turbidity in rural areas, turbidity can be a determining factor for fish diversity. Soil erosion is severe in Korea because of agricultural practice is not eco-friendly. We dig soils very easily. So we disturb topsoils a lot, and turbidity problems are ubiquitous in rural areas. Eutrophication is also a problem, major water quality problem in a reservoir. In Korea, I categorized reservoirs according to the water quality, and I see 68% of reservoirs are eutrophic, and cyanobacterial blooms are common even in drinking water supply reservoirs. With the eutrophication and increase of phytoplankton, hypoxia is a major stress factor to aquatic ecosystem health. Because of anoxic bottom, benthic fauna can survive only at shallow surrounding area. And another problem is high pH in eutrophic lakes. With the increase of photosynthesis, CO2 is taken up and pH go up over 9, sometimes over 10. Over 10 is very common. By Korean water quality standard, the guideline is 8.5, but often it goes over that value. This is the cumulative distribution function of pH in Korean reservoirs. We don't have acidic lake below 5.0. We don't have acidic lake. Instead, we have many alkaline lakes. over 8.5. About 15% of reservoirs show alkaline conditions. And also we have high supersaturation of oxygen in the surface area. This is a eutrophic lake with cyanobacterial blooms, and we see 150% of oxygen supersaturation. And in order to understand the state of reservoir water quality, we need to have a distribution function of water quality for each area. I summarized some distribution function, and I developed a lake water quality index from this distribution function. This figure shows a distribution function of COD in Korean lakes. 0 means the lowest COD value, and 1.0 means highest probability. So from this function, I gave a score to this function. I mean a score to the percentile position of that reservoir. So I gave 0 score to the worst case, and I gave 100 score to the best case, and 50 means median value. And I fitted that distribution to a logistic function model. Logistic function model has an S-shaped curve. You know TSI by Carson. It is a well-known model for indicator, but it is a log linear model. Log linear model is very sensitive to extreme values, when the value is very low or when the value is very high. But logistic function model is very robust to that kind of extreme values. So I made distribution functions for water quality variables, Korean reservoirs, and I made water quality index. I named it LQI. This LQI has a unique feature of it is a relative assessment index, not absolute assessment index. Yeah, each country or each district has different conditions. Some area is very pristine, and some country are very eutrophic. So, in order to assess precisely the status of that reservoir, we need a relative index. So I made it. And the value is from 0 to 100, which is very intrinsic. Then, what are causes of eutrophication in Korea? This is national phosphorus budget of use in Korea. Fertilizer is 41%, and animal feed occupy 36%. Human use occupy only 20%. Then, what are sources of phosphorus discharge? The best one, major one is the sewage. Yes, of course, we treat sewage at the sewage treatment plant, but BOD removal is common in Korea, but still phosphorus removal is not good enough, not enough. So in many cases, sewage is still a cause of eutrophication. And second, organic compost. Yeah, organic compost is made of manure, livestock manure. In European countries, organic farming is eco-friendly farming because they don't have heavy rain showers and their land is flat. The compost is not washed out on rainy days. But in Korea, we have heavy rains in summer and most of uplands are steep. So on rainy days, organic composts are vulnerable to erosion. and it is washed out to reservoir, and it causes eutrophication. Chemical fertilizer, I measured fertilizer phosphorus budget in a watershed. I found out only 5% is discharged out of the watershed. Most of chemical phosphorus fertilizer is absorbed to topsoil. We had some controversy about the relative contribution of point source and non-point source of phosphorus. Some people say point source is more important, others say a non-point source is more important. But it depends on the location and size and residence time of a lake. In large dams with a long residence time, agricultural runoff is stored. Heavy rain runoff is stored in large dams, so agricultural non-point source is a major cause of eutrophication. But in downstream reservoirs or rivers, rainy days, the residence time is very short. Much of phosphorus is just washed out to downstream or to the sea. And sewage treatment, plant effluent, is the major phosphorus source in dry days. So in that reservoirs, in downstream reservoirs, algal bloom occur in drought condition, not rainy season. Okay, this is a graph showing the impact of sewage treatment plant effluent. There are two graphs. One is the phosphorus concentration in the river, and the other is phosphorus in the sewage treatment effluent. They are same. That means the river water is mostly composed of sewage treatment plant effluent. Actually, there is no natural river water on dry days. We have many dams, and a river is diverted, and dam water is used in the city, and sewage is discharged in the river again. This figure shows a case of the effect of sewage treatment plant effluent on eutrophication. This is Lake Gihung near Suwon area. After the construction of sewage treatment plant at the shore of the lake was severely eutrophied. And in large dams, we have shock loading of phosphorus on rainy days during summer monsoon. And after summer monsoon, we have algal bloom in August and September. So I named it monsoon bloom. So I think it is a good name, monsoon bloom. So in Korea, we have monsoon bloom period in August and September, and we have clear water phase in winter and spring. Then, what can we do to control eutrophication? Of course, we should remove phosphorus in the watershed from the sewage, and we should reduce phosphorus in the agricultural field. Yeah, it is a very good preventive method, but in many cases we can't do it. Then in that case, we should do in-lake treatment. Okay, first we should remove phosphorus from sewage. Yeah, sewage treatment is very common in Korea. Most of sewage is treated, but still we have phosphorus in the sewage treatment plant effluent. Raw sewage has 2 milligram per liter phosphorus. Treated sewage has 0.2 to 2 milligram per liter phosphorus. But it is much higher than the criterion of eutrophication threshold, which is 0.03 milligrams per liter. So about 5 times or 10 times higher than the threshold of eutrophication. So we should remove phosphorus more. It is not good enough. This bar shows TP in the sewage treatment effluent. That means treated sewage. And the bottom line, at the bottom line, some errors. At the bottom line, I put a line of 0.03 milligram per liter, which is the eutrophication threshold level. The TP in the sewage treatment effluent is much higher than a threshold level. So you can see that sewage treatment plant effluent is still the cause of eutrophication. So we need more removal of phosphorus, more advanced treatment. And the second, in order to reduce phosphorus from agricultural non-point sources, I think we should reduce livestock production. Yeah, as you see, livestock manure should go back to the plant. But we import a lot of feed, animal feed and human food from America and Australia and other countries, but the manure is not exported back. So we have accumulation of livestock manure, which is much higher than environmental capacity. Environmental capacity, some experts calculated it. It is more than three times of environmental capacity of Korean peninsula. So finally, I will talk about in-lake treatment. Yes, in many countries, even in developed countries, we couldn't reduce phosphorus discharge from agricultural field. Still they have, in European countries, in America, still they have eutrophication problems. It is very difficult and costly to reduce phosphorus in the agricultural practice. So in that case, final method we should resort is in-lake treatment by alum. Actually, this method is recommended by North American Lake Management Society. In their home pages, they have a booklet about the phosphorus inactivation, and they recommend that this is a very safe, and very effective, and very economical method. Alum is very safe because it has been used for water treatment for 100 years, and it is very safe and effective. Okay, finally, I summarize the factors threatening freshwater ecosystem health in Korea. Physical factors and turbidity, eutrophication factors, and eutrophication in streams, and biological factors. So, thank you for your attention. I hope it helped you understand Korean limnological conditions, natural conditions, and cultural conditions both. Thank you very much.
Thank you so much. Valuable presentation. Would you have any question? Okay. So, Professor Kim, would you give us more information and comment on further study on freshwater ecosystem, especially related with and the water quality and plankton interaction?
Recently, we had great concern about the harmful cyanobacterial blooms. But still, we don't have any effective method to control eutrophication. Many people warn the harmful or hazard of eutrophication, cyanobacterial blooms, the toxic and algal blooms, but we don't do much to control them. So I think we should spend more energy to control eutrophication than monitoring. I think we have a very effective, good, intensive monitoring system now in Korea compared with the control method. So I think we should treat more sewage. We should remove phosphorus from sewage more, and we should use some alums to control toxic algal blooms like that. Yeah. So that's my idea.
Yeah, thank you so much. Okay. So I would like an announcement for today's program. Thank you so much, Professor Kim. Okay. Okay. After this plenary lecture, there will be SIL General Assembly and the SIL International Committee meeting. Anyone who has registered for SIL 2021 can join the SIL live program without having to log in. Okay? When the plenary lecture ends, leave the link and click the program of the live program to participate in program. Okay. I appreciate your active participation. Okay. Thank you so much again for attention. Thank you.